Hey guys, welcome to Day 4 Notes, Solving Rational Equations. Try and keep this video under 8 minutes. I'm going to try to do that. That's my goal. But I'm only going to give you 3 examples, so it shouldn't take too long. And we've already done adding and subtracting, so we're going to use what we learned about common denominators to solve some of these. But I will give you probably a little homework check over the video tomorrow at the beginning of class, so hopefully you're watching this. And I'll probably ask you about a few of the examples on here and then maybe give you a couple of new examples to kind of see where we're at. But here's a picture of my family. It's kind of an older picture. My son and daughter are pretty young here, but it's a pretty good picture. And I do have rights to show their picture because I am their dad. So that's my wife and my son and my daughter there, just in case any of you are wondering what they look like, since I talk about them a little bit. But anyway, let's talk about solving rational equations here. Example 1 here, solve 2x minus 1 over 4x equals 4 6. Now one way you can solve this is you can cross multiply because it is a proportion. A proportion means one fraction equal to another. So you could just cross multiply and get rid of the fraction and solve it that way. But I'm going to show you a little bit different way, and the way that I'm going to show you works for all of the examples that I'm going to give you. So that's why I'm going to show you this method, because it works for all of them. So what we're going to do is we're going to take this and we're going to look at the denominators 4x and 6, and we're going to find a common denominator between 4x and 6, the lowest common denominator between 4x and 6. So the smallest number between 4 and 6 would be 12. And then I have this x here, so I have to include that as well. So my lowest common denominator is going to be 12x here. Now, what I'm going to do when I solve this is I'm going to multiply each one of these fractions by 12x. So I'm going to take 2x minus 1 over 4x, and I'm going to multiply it by 12x. And when I do that, the 4x and the 12x will reduce. And what I end up with is 3, because 12x divided by 4x is 3. And then I have to multiply that by what is on top, which is 2x minus 1. And that's going to be equal to, and here again, we've got the 12x, we're going to multiply it by 4 6. So we take 12x and divide it by 6, which is 2, and so I have to multiply that 4 by a 2. Now another way of looking at it is if 12x was my common denominator, for both of these, from 4x to 12x, I multiplied by 3, so that's what I have to do in the numerators, multiply by 3. And then here, to go from 6 to 12x, I multiply by 2, and so that's what I have to do in that numerator. And that's the same concept that we did when we were adding and subtracting fractions yesterday, or today in class, actually. So now all we have to do is distribute and solve. So when we distribute here, we end up with 6x minus 3 equals, and I have made a boo-boo here. 12x divided by 6 is actually 2x, guys. Sorry about that. So we should have 2x times 4. So over here, that would be multiplying by 2x. So some of you might have been like, well, he's confused, and I get that sometimes. I usually make about 2 mistakes a semester, so there's one of them right there. But anyway, so this should be 12x divided by 6 is 2x, and then I multiply that by the 4 there. So now we have 2x times 4, which is 8x. And now we just solve this. I'm going to subtract 6x to the other side, and I get negative 3 equals 2x, and then divide by 2, and we get negative 3 halves equals x. Solving rational equations. Okay, now we're going to do all of the examples like that. We're going to get a common denominator, multiply it through, and that will get rid of our fractions throughout the problem, and we won't have to deal with them anymore. So let's take a look at another example here. So let's solve x plus 3 over x plus 1 equals x plus 5 over x. Now, we do have 2 terms that have a common denominator here, the first term and then this x plus 5 over x over here, but I'm still going to do the same thing. I'm going to multiply the entire problem by the lowest common denominator, and then I'm just going to get rid of my fractions and then solve from there. Now, here, this is a 1, but that's over 1. That's understood. Okay? So if I'm looking at x, 1, and x, my lowest common denominator is simply x. Now, that makes life kind of easy here. So now I'm going to take each one of these terms and I'm going to multiply it by this x. So x plus 3 over x times x, what happens is the x's cancel out and I'm just left with x plus 3. And then here, if I take 1 over 1 times x, I end up with x. And then here, x plus 5 over x times x, again, the x's cancel out with each other, and I'm just left with x plus 5. Now this looks a lot better than what we started with. So now we're going to combine like terms here. So we end up with 2x plus 3 equals x plus 5. Again, get like terms together. So subtract the x to each side here. I'm going to subtract the 3 over here. So we end up with x equals 2. And that is my final answer. And if you want to check that to see if it works, you can. You could plug in a 2 for x and you should get this to equal out to one another. Alright, so there's example 2. Alright, so one more, example 3 here. And I got like a minute and a half to do it. I don't know if I can do it in a minute and a half, but we're going to see what we can do. Alright, example 3. X over x plus 3, again we're solving this, minus x over x minus 2 equals 10 over x squared plus x minus 6. Now, before we solve this one, we need to factor this denominator over here, because you can see we have all three denominators are different, but we need to see if we can factor this one, and maybe that'll help us in the process here. So we're going to factor this, and that factors into x plus 3 and x minus 2. And that worked out nice because over here I have an x plus 3 and an x minus 2. So now, if I'm looking at the entire problem here, my lowest common denominator between all of these, well, we have an x plus 3 in common here, we have an x minus 2 in common here. So we got to have both of those in the denominator. So x plus 3 and x minus 2 have to be in there. So here, if I have an x plus 3 as my denominator, and let's just say this is my new denominator, just like we did with adding and subtracting. So what if I multiply this by to get to here? I multiplied it by an x minus 2. So that means I have to multiply that top by x minus 2. So I'm going to have x times x minus 2. And then here the same concept. If this was my denominator and this is now my new denominator, because it's the lowest common denominator, x minus 2, I had to multiply it by an x plus 3 to get to here. So that means I have to multiply this top by an x plus 3. So I have minus x and then times x plus 3. And I put the minus there because that's what was in the original problem. And then equals, now here, notice that the denominators are the same as what I'm multiplying by. So all that would just cancel out and I would end up with 10. Right? So now, we're going to multiply this out here. We're going to end up with x squared minus 2x minus x squared minus 3x equals 10. If we combine like terms, the x squareds cancel. I get negative 5x equals 10. We divide by negative 5, and x equals negative 2. Now, I do need to make sure this answer does work. And what I mean by that is when I plug it into the denominators here, do I get 0? Because you cannot divide by 0. So here, if I plug in a negative 2 plus 3, I get 1. I'm good there. Here, negative 2 minus 2 is negative 4. I'm good there. So that means it would work over here as well. So that answer is going to work. All right. So I'm at 9.5 minutes. I'm a minute and a half over. So still trying to get that 8-minute mark. But take a look at this. If you have any questions in class tomorrow, please come in ready to go, and I'll be happy to answer those. See you soon.